Okay, this is problem 9. So we're given this this function here, and the first question asks for the domain. So basically, when you're looking at the domain of a function, you're looking for places where it's well defined. Usually there's 3 things you want to look out for. The first one is dividing by 0. The second one is taking the square root of a negative number. And the third one is taking the log of a number less than or equal to 0. In our case, the only thing we have to worry about is dividing by 0. And so that happens when x is 1. So we know that x cannot be 1. So you can write it as a union of these 2 intervals, or you can just say that x is not equal to 1. For the second question, it asks us to simplify it. In my mind, this is a retarded question because what's simple? Anyway, I think what he wants you to do is just factor it. So if you're like me, I'm really bad at just seeing things, seeing quadratics, and knowing what they factor to. So I always use the quadratic equation, which is right here. And so in this case, it works out to be this, and that gives us these 2 values for x. And so we can rewrite the numerator here as x minus the root that we got times x minus the second root that we got, or x plus 1 times x plus 2. And so that's how this guy factors. And so we can write the function like this. Question C asks us to identify any vertical asymptotes. So that happens when the denominator is 0, but you want to make sure that the denominator won't cancel with anything in the numerator. So it was a good idea that we factored this first, in case there was an x minus 1 up here that would cancel with this. At any rate, we know that at x equals 1, there's a vertical asymptote. Now for question D, we're asked to find the oblique or horizontal asymptotes. For this question, there are no horizontal asymptotes because the numerator power is greater than the denominator. So when that happens, you won't have an oblique asymptote, or you won't have a horizontal asymptote. But we do have an oblique asymptote, and you find that by doing long division with the polynomials. So here we've got our numerator, and we're dividing that by the denominator. We need to multiply x times this to get rid of the x squared. So when we do that, we'll get, x times x minus 1 will give us x squared minus x. So we subtract that from this and get 4x plus 2. And then we'll have to do 4 times x to get to cancel this. So 4 times x minus 1 will give us 4x minus 4. So when we subtract that, we'll be left with 6. So we can rewrite our function as what we got when we divided it, plus the remainder over the denominator. And we see that as x gets large, this part goes to 0. So we're left with x plus 4. Means that as x gets bigger and bigger, the function gets closer and closer to x plus 4. So this is our oblique asymptote. Now, your professor had a couple of E's on here, I think. This was the first E. We're asked to find we'll have to check for symmetry. So you do that by plugging in a minus x everywhere for x and checking to see if it equals f of x. So we stick a minus x in here where the x squared is, a minus x in here where it was just an x, and a minus x here. So this simplifies. The negative sign here disappears because of the square term, and then here it pops out. Same with here, it pops out. And you can see that this function is not the same as the original one because of these extra minus signs here. So you'd say no, there's no symmetry. Now for the second E, we're asked to find the y-intercepts. So you do that by setting x equals 0, as is done here, and you just get minus 2. So that means the only x-intercept happens at 0, minus 2. That was the y-intercept. For the x-intercept, you set y equal to 0 as such. Now this will be 0 when the numerator is 0, and so we can see that will happen when x is minus 1 and when x is minus 2. So our intercepts are just minus 1, 0 and minus 2, 0. Okay, part G asks us to find or to determine if at x equals minus 2 and x equals minus 1, if it crosses the x-axis or if it just touches it. So what we do is we look at our factored form. Now there's only three places where this could change sign, and that's at the 2 roots and at the asymptote. So we want to look to the left of minus 2, in between minus 2 and minus 1, and to the right of minus 1 to see what happens at these points. So when x is less than minus 2, then this will be negative, this will be negative, and this will be negative. So we'll have a negative times a negative divided by a negative, which will give us a negative number. So we know that to the left of this, it's negative. For x between minus 2 and minus 1, this will still be negative, but this number will now be positive, and this one will be negative. So we'll have a negative times a positive divided by a negative, which will give us a positive. And lastly, between minus 1 and 1, we'll have a positive times a positive divided by a negative, so it'll be negative. So this tells us that left of minus 2, it's negative. Between minus 2 and minus 1, it's positive, and to the right of minus 1, it's negative. So it have to cross at minus 2 and again at minus 1. Now we've done most of part H now, because we're asked to find where it's above and below the x-axis. So we already know that it crosses at minus 2 and it crosses at minus 1. So we just have to check to the right of positive 1. And so if we plug in something greater than 1 into all of these, they'll all be positive. So a positive times positive divided by a positive, which will give us a positive number. So we know that it crosses at minus 2, and then again at minus 1, and then again at a positive 1. So here's my very crude graph of this. Sorry, I'm not very good at graphing. But we've got the vertical asymptote at x equals 1, and then we've got the x-intercepts at minus 2, minus 1, and then the y-intercept at minus 2. So we know from the work we did over here that it's negative, positive, negative, positive. So we know it's got to be negative over on this side, and as it goes farther and farther out, it's going to follow this line, which is the oblique asymptote. And so it just kind of curves around like that. And then it comes up positive for a little bit, and then dips back down and goes negative along the vertical asymptote. And then from our little chart over here, you'll see that it's positive to the right of 1. So it's going to look something like this, where it comes down from positive infinity and then follows the oblique asymptote. So that's roughly what it looks like. My scale isn't very accurate here, but that's what you get.